Okay, so now we're going to talk about adding vectors and subtracting vectors. So they talk about three methods of adding vectors in Edgenuity. The first way to add vectors is called head to tail. So if I have two vectors, say this one, and we'll call it u, and then this one, we'll call it, we'll call it v. Okay, and if we want to add those two, we basically put the head of one angled to the tail of the other. So this would be v. And then the resultant vector would be the sum like this. That would be u plus v. I am not a huge fan of the head to tail method because it doesn't really give you any frame of reference. So this, however, u plus v is called the resultant vector. Okay. All right. So another way, or the second way, and this way I like a lot better, even though it seems to be a little bit more work, is called the parallelogram method. Okay, so what I'm going to do is I'm going to do this on a XY axis just to make it a little easier. Okay, so here is one vector. Okay, and I'm going to add it to another vector. Okay, so how you get your resultant vector is basically what you do is you make a parallelogram. Doing this the best that I can. Okay. And then what happens is that the diagonal of the parallelogram from the origin will be the resultant vector. Okay, so let's stop drawing pictures and actually try this out. Okay, I'm going to zoom in, make my graph a little bit bigger. So example. Okay, let's say u is the vector 3, comma 5. V is the vector 2, comma 10. So they're in component form. Okay, I might keep everything in the first quadrant. Just to keep everything kind of nice. Okay, so let's graph. All right, here we go. 3, 5. So there's my first vector. Okay, second vector, 2, 10. Yep, 2, 10. Okay, so there are my two vectors. Okay, so now we're going to draw a parallelogram, or at least try to. Okay, so what we want to do is we want to move the green vector. Okay, that's u. This is v. So again, so let's see, we have a slope of, so again, this takes a lot of drawing. Okay. All right, next one. Okay. All right. Now, if I draw the diagonal, it should wind up where my resultant vector is. Right there. Okay. All right, so let's see where that ended up. So that ended up at 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So by the parallelogram rule, I wound up at 5, comma 15. Okay, have you noticed a simpler way? Okay, so this brings us, okay, to the third way of adding vectors, which is probably what you guys are going to use. We'll call this numeric. Okay, so given a, b as a vector plus c, d as a vector, to find the sum, you just add the horizontal components and add the vertical components, and you are all done. Okay, so if you were given a vector -3, +10, plus 14, -11, add those. -3 plus 14, 10 plus a -11, you could probably do this in your head, 11, -1. Okay, now let's talk about vector addition for just a second. Okay, vector addition is commutative. So what that means is that u plus v as vectors is the same thing as v plus u. Okay. However, okay, magnitude, you have to be careful. Okay, so the magnitude of your resultant vector is not equal to the individual vectors added up. Okay, so let's prove that. Okay, so let's find the magnitude. Let's use my previous example. Okay, and we're going to show that the above is actually not equal. So the magnitude of u, again, we can use a double bar or a single bar. So negative radical 3 squared plus 10 squared is 109 square root. Magnitude of v. Let's see, 196 plus 121. 317. Okay, I'm going to find the magnitude of u plus v. That's going to be 11 squared plus negative 1 squared. So that's 122 square root. Okay, so let's prove that they're not equal. Square root of 101, or 109, excuse me, 313, is that equal to the square root of 122? Hopefully you're saying absolutely not, but let's just double check my decimals. Okay, so, and again, I'm just using my calculator here. Okay, that's approximately 28.24. And then $11.04. So those are definitely not equal. Okay, so again, the individual magnitudes added together does not equal the magnitude of your resultant vector. Okay, all right, so this was a very, very basic intro into adding vectors. Again, you have 3 ways. You have head to tail, which you will see Edgenuity use. We'll get to that in our next video. The parallelogram method, which is kind of my favorite method to use for addition. Okay, then you have the numeric method, which everybody seems to like the best because it's faster and there's no graphing. Okay, and then you know something about the magnitude. Okay, so next up we will talk about vectors and polar coordinates.